Found it. Okay. Hi, everyone. Thanks for coming out. Oh, we got more people trickling in, and hopefully more will trickle in online. Thanks for coming out to the August meeting of the Howard Astronomical League, our monthly meeting. We got some interesting stuff to talk about and a very interesting speaker I'm excited to hear about. And so our agenda for tonight, introductions, got some announcements, again, an excellent speaker, and then we'll do our regular what's out in the sky and go through some images and whatnot. So first, introductions. Is anybody new online or in the room that would like to say hello?
John and Ann Worley. We're just here to learn a bit, so.
Great, welcome. Are you members or not?
We are indeed,
Okay, well, that's why we're all here, to learn.
yes.
I sometimes these younger people at work put in they write text message that says TIL, and I didn't know what that was. Recently I looked it up and it said, "Today I learned." Yeah, so now I will today I learned TIL. Every day I come to do something with HAL, I learn something new. So great, welcome. There'll be some time at the end of it. We can talk a little more if you want to chat about the club and what we're doing and whatnot. Jeff, you want to?
Yeah, I'm Jeff Plinus. I've been a member for a while. I just have not been to meetings very much lately. So I'm kind of making my way back, kind of prodigal-like.
Great. Welcome back. I want to look through your job one of these days.
You bet.
Anybody online want to say hello? It's okay if you don't. All right, well, I'll just go ahead and get started then. So announcements. I got a big announcement, first of all, which is our meeting date. Our meeting dates going forward is changing. We've been here at the Robinson Nature Center on the third Thursday of the month for as long as I can remember.
Since they built this.
Yeah, like I don't know, at least 10 years that I'm aware of. And next month, just to accommodate some of the other scheduling that's happening here at the Robinson, they've asked us to see if we can move to the second Thursday. So I'll send out, like I always send out my reminders, and we'll update the HAL calendar and all that. But going forward, it will be the second Thursday. So the 11th of September, the 9th of October, et cetera, et cetera. So in part of our agreement with the Robinson Nature Center, why they let us use this nice facility for our meetings is because we volunteer at events here. There's Phil can talk to this better than I can, but there's solar viewing events where we come out with our telescopes and et cetera. But one of the things that they need right now, there's the planetarium here. If you're interested in learning how to operate and run the shows, planetarium shows here, then get in touch with me, or if you know Joel Goodman, our treasurer, just reach out to somebody in the club and we can facilitate it, because that would be really good. We've already gotten a few, but the more the merrier. Okay, so second Thursday of each month going forward. Star parties, we've got some coming up. What is today?
21.
21. So I put my red circle in the wrong spot. There's a members coming up this Saturday. So the next two are the members this Saturday, and then the public. This is what happens when you make your charts late the night before. Public star party on the 13th with no moon, and members this Saturday. I think tomorrow night's the forecast is really good. I'm not sure what it is for Saturday. But keep an eye out and, for notices, and, that'll be at Alpha Ridge. Other, recent events, we had a star party on the 2nd of August, a public star party, and there were maybe 120 people, according to Jose's, report. 17 people set up their telescopes. Crystal was once again nice enough to set up her activities tent and entertain, students, and she brought one of her high school students. And Dale inside, the inside running Halo, David Stein, etc. So thank you to all of those folks who came out and set up their scopes. At the other, we had a couple of impromptus during the month that were interesting, especially because the meteor shower drew a lot of attention. So on the 12th in particular, Ernie Morse had lots of non-members coming out, and you know, crashing the gate crashing, party crashing at Alpha Ridge. But he was very kind to open the gate for them and kind of show them the ropes. I don't know, if I had to guess, there'll probably be a couple of new members that sign up because of that. Because him and Jose are very nice, and they share a lot. As it turns out, there was not a lot of meteors that night, but Ernie, with his cell phone, took a picture of this strange dumbbell looking thing. That picture there on the right, some kind of strange rocket fuel dump, created an interesting, dumbbell nebula like object. So anyways, coming up in terms of star parties, we've got next Friday, in addition to the Robinson Nature Center, we also partner with the Howard County Nature Conservancy. They're up on Route 99 there in Marriottsville. They often let us use their, grounds. They have a really nice view of the western horizon. So when there's a comet or something real low in the sky, they let, HAL members come and, use their grounds to to view and to image. So, so, we also kind of get back with them, and one of the things is we're gonna hold a star party for their members. So it'll be just like a public star party where we set up our scopes and show people the wonders of the night sky. But it will not be at Alpha Ridge. It'll be at their facility. And if you go to our website, there's, links with Google Maps and all that. So if you can make that, it's great. They're somehow charging $5 to get in, but if you type in it'll be waived for HAL members. Both, did you try both of the ones I sent? Oh, they're having, I have to email them again. They're having some website problems.
Big deal, but it wasn't working.
Yeah, I got frustrated and just paid the $5. So anyways, yeah, I'll reach out to them and see if they can figure that out. And thanks for letting me know, Phil. So the other thing that will be coming up, in September, and it actually is the same night as our September's, members star party, is the Astronomy Festival on the Mall. It's literally on the mall in DC, right outside the one of the museums. I forget which street. I'll have the details for you. But it's kind of an interesting event. We're gonna set up a HAL table and hand out swag and and tell people about HAL, along with there'll be a number of other vendors and organizations that'll have booths set up, and a lot of solar scopes, because it's going to start at 5 in the afternoon and sunset that night is like 8:20 or something, and or maybe earlier than that. But so if you have a solar scope and want to share views, I'm bringing my scope. I'll set it up there, on the grass just, outside off the main area of the mall there, and it's not the best place for light pollution, but I think Saturn will be up enough to see. I need to double check. Anyways, yeah, so that will be happening on the 20th, and I'll send out a more notice to the club. If you can make that and volunteer, it's actually quite fun. I had a huge line. I met a lot of people. I got some nice people come and give us, we had some good speakers just from contacts made there. And then also, there was just tons of people that were just interested in, and there was a line of 15 or 20 people the whole night at my scope. So, anyways, and then there's another event coming up in October at Glen Elg School. It's the Solar Science and Engineering Celebration, and I will let Krystal talk to that.
Yeah, so everyone, this is my second year hosting as a part of the Maryland STEM Festival. The Maryland STEM Festival is a month-long celebration of all things STEM, and they encourage, schools and organizations and clubs throughout Maryland to host events to engage the community in, lifelong learning and relation systems. So my event is called the Solar Science and Engineering Celebration. It will be on a Saturday, October 18th from 12 to 4. The two major highlight areas, I guess if you'd want to word it that way, is solar telescopes. So weather permitting, I will have the Gould Observatory open with the white light filter, and the Howard Astronomical League is kind enough to participate as an organization, so they'll have a table, and I'm also counting on a few members to bring their solar telescopes along with other demonstration tables that might have like meteorites and other things interesting for astronomy. We'll also have tons of hands-on engineering challenges for K through 12, so building solar sails and lunar landers and making UV bracelets. So the goal is really just to have this event be free and open to the public, really engage people in a love of science and engineering and getting them to come to the campus and have a great day. If you have any questions, please feel free to contact me or email me. If you're interested in volunteering or you think you know an organization that would love to participate, please also send that information my way as well. Last year, I had the University of Maryland College Park and Baltimore campus participate. They set up booths and tables. The Howard County Library Systems participated as well, and including some engineering clubs from local schools and even some schools from Virginia. So it's a great event. I really encourage as many HAL members to bring their families as, you guys are welcome. And it's a great outreach effort to just get people excited about the sun and get them excited about, some outdoor STEM activities.
Thanks, Krystal. And having, who were the people that had the robotic dog last time?
That was the Howard County Library System. So they have something called the STEAM machine. It's kind of like a RV that's fitted for STEM activities. And that particular day, I guess the vehicle broke down, but they were able to bring the robot dog. And honestly, I think that was the highlight of the event. Everybody really went nuts for the robot dog.
Yeah, I had fun with it. All
It
right,
was
well,
pretty cool.
great. Thanks, and thanks for organizing this. I hope I hope you have more help than last year. You were pretty busy.
Yeah,
So,
thank you.
all right, great. So another announcement is that, I'll come back to you next, Krystal, with the book of the month. But we have a member who this month received a observing award. I was hoping that Steve Jaworski would be here to announce this because he's our Astronomical League coordinator, but he had a conflict and that he couldn't get out of. Um, so, anyways, Greg Duncan, club member who received the double star observing award, where he visually observed 100 of the finest double and multiple star systems and documented his observations in a logbook, and then he submitted it to the Astronomical League, and then he got his pin. So congratulations to Greg. Yeah. Greg, I live in the same neighborhood as Greg, and I see him when he sets out his telescope out sometimes. So I'll make sure to, if he's not online, I'll make sure to congratulate him when I see him. And so as long as we're on the subject of the Astronomical League, it's an eye chart, and I don't expect you to read it. But there is a link at the bottom that if you are interested in, these programs are good because they have lists of some of the most interesting things to image or view. There's a carbon star, all these red stars. I keep meaning I want to do that one.
Yeah.
and so a list of the various observing programs is here on the right hand of the slide in microfiche. Not for you to read it, but just so you can just get a feel for how many of them there are. So I'd encourage our members to, if you want to familiarize yourself and enjoy some of the better and more interesting objects to view at the eyepiece, I encourage you to go look at these on the Astronomical League website. And so Steve can thank me for giving me his talk, his his little blurb there when I see him next. Okay, so next we have our book of the month, and you're up again, Crystal.
Yeah, so this month's book of the month is Chasing Space, an Astronaut's Story of Grit, Grace, and Second Chances by Leland, Melvin. It was originally published in 2017. A former NASA astronaut and NFL wide receiver shares his journey as the only person to catch a pass in professional football fields as well as in space. So his inspirational book really highlights the importance of community, faith, and commitment in the pursuit of success. Melvin kind of brings us along this remarkable trajectory of his life. He provides a really honest reflection of his setbacks and his triumphs, while also urging the reader to go the distance to kind of achieve what you define as your impossible. I appreciated the way that Melvin celebrated the people in his life that gave him second chances, advice, and support. This book offers a really uplifting reminder that the right stuff, as NASA might define it, is different for everyone. I recommend reading Chasing Space. There's also a young reader's edition as well. I picked up the book as a great way to just find some motivation before the beginning of the school year. And so, despite having a ear injury really early on in his training for becoming an astronaut, he was still able to fly up to the International Space Station and operate the robotic arm. And so it's a great book. I highly recommend it if you're looking for something uplifting and to give you that reminder of the right stuff.
Awesome. Thanks. Thanks for another excellent review and recommendation. Okay. Anybody got anything else before we jump into our speaker? So Andrew, you should be able to share your
Just got a
screen.
question.
Okay, we got one question.
On your first slide, it says Tuesday, but later on you say Thursday,
Did I do that again?
the thing.
Did I say,
It does say second Tuesday of the month.
Yeah.
I keep doing that. I something,
Second Tuesday, correct?
no, it's the second Thursday of the month.
Second Thursday, right? Oh, yeah, right.
Second
I
Thursday.
keep doing that and because it's the second one, something in my brain switches Thursday to Tuesday, like the second day. So thanks for catching that. Yeah, no, I'll have to correct that before we post the slides. Thanks. So yeah, second Thursday of the month, going forward.
When's that starting?
Next month,
Next month?
September,
Okay.
the Thursday, the 11th will be our next monthly meeting. Okay, so our speaker tonight is Andrew Hamilton. He's the Deputy Chief of the NASA Balloon Program Office. And so he has been previously the acting chief of the program, but before that, he's been at NASA his whole career at Johnson Space Center as an astronaut instructor. Maybe he knows Leland. Maybe I almost wish we would have reserved a different section of the talk for some of those things, because you probably have some super interesting stories from those days. But anyways, so yeah, he was an instructor and transferred to Wallops in 2012, where he was a range safety officer and is now deputy chief of the balloon program. So without anything further, I think I will stop sharing and let you share your screen.
Okay, fantastic. Give me 1 second. And hopefully that's coming through for you guys. And I'll turn on the camera for just a minute. you guys can see, let's get a video. So, hey, thanks for the opportunity to talk with you guys. And actually, I do want to comment on the book Krystal talked about, even though I haven't read the book. I can endorse it because I did work with Leland quite a bit. He was a super good guy to work with, fantastic work ethic and fantastic everything. And yeah, that whole ear injury he had when he was doing his dive work in the NBL, that really kind of threw a kink in things, but he worked through it and got to ride on the space station. So good for him. Great guy. All right, let me kill the video so we don't need to see that, and we'll get on. So thanks for the intro. Appreciate it. Yeah, I've been with NASA quite a while now. As you see, I've done quite a few things. Actually, before that, I was in the Navy. I was a pilot for the Navy, which is how I got to be working at Johnson Space Center as an instructor for the astronauts. All right, so here tonight, we're going to talk about balloons. All right, so first off, what are we and what do we do? So the mission of the balloon program is, without reading it verbatim, but we do provide low-cost, quick access to the near space environment and allow for cutting-edge science and technology investigations. So everything's relative, right? You know, low-cost, quick response near space. But the thing that I like to point out in this sentence is, we do observatory class payloads. So think of James Webb or Hubble or Chandra or whatever your favorite observatory satellite is, and hang that below a balloon. And that's the kind of science that we do from the stratosphere. We do serve as a technology development platform for future space missions. So many times we'll have folks that will bring us a thing that they're using to develop and make better for either a follow-on balloon or a follow-on mission. And we've had many examples where the equipment that they've flown, that they've eventually turned that around to fly on a satellite or a space station or something like that. So it is a great platform in which to do this kind of science. And then the third leg of what we do is with training of students and young scientists. So it's a great platform for folks that are, students are very early in their career to get in there and do developmental work, do the science, and really cut their teeth on some good cutting edge stuff before they move on to bigger science and bigger payloads and whatever else. So it's a very nimble, flexible, agile kind of platform that serves a lot of different parts of the community.
Andrew?
Yes, sir.
Do you want us to hold questions to the end, or do you want people to?
I'll take questions at any time, but I just can't tell when folks have a question, so you may have to interrupt me.
Okay, and actually I can't either because I'm in the audience now, but if anybody at home on Zoom, if somebody raises their hand, could somebody please notify the room?
Cool.
Wayne usually does that.
Yeah, we'll keep an eye out.
Fantastic.
Oh, so I already have a question.
Yes, sir.
So your missions, are you doing like earth sciences or space sciences?
So we serve all science communities. Most of what we do is looking up. So we're doing astrophysics, heliophysics, that sort of thing. But we do serve atmospheric science, earth science, and the other pieces of the science community as well. So we don't, limit ourselves to just one part of the scientific spectrum.
I see. And we, just to let you know, we had a speaker last year who talked to us about the SOFIA program. I don't know.
Oh, yeah.
Yeah. So maybe you share a lot of common. Okay, I'll let you get on with your talk. Sorry.
Yeah, actually, I took some of their money and some of their parts when they shut the program down. All right, so a little bit about the program, what we are. So actually, the program is located in Wallops Flight Facility, which is part of Goddard Space Flight Center. You guys are probably aware of that. We are funded through the Astrophysics Division of SMD, but like I was just saying, we do serve all the scientific disciplines. because there's a lot of different things that can be flown on a balloon, either whether they're looking up, looking down, or looking sideways from the stratosphere. We do support the DoD and other government agencies. We're always working with the national labs like the Naval Research Laboratory, AFRL, Sandia, those sort of places, so to help do their developmental and technology work. We do a lot of technology demonstration flights. In fact, we just had one today. It launched and landed today. So, and that's part of the mission that we do as part of our own internal development to work on technology. And of course, we have frequent education missions. And that goes back to that third leg I mentioned on the previous slide about the students. We have every year a dedicated mission that's just for college students. It's run through the Louisiana Space Grant. It's called the High Altitude Student Platform, HASP. And that program has been going on for a very, very long time. But there are others that we deal with. Generally, our student audience is undergrads and young postgrads, but we do have some programs that deal with middle school and high schoolers as well. At any one time throughout the year, we've got 20 to 30 flights that are in development. So we have a fairly busy schedule. And each year we'll launch about 10 to 16 missions from our various locations, which we'll talk about those in a little bit. So that's the program management. Now on the execution side, that's handled through the NASA Balloon Operations Contract through our contractor in Palestine, Texas. Now I know it says Palestine, but in Texas they pronounce it Palestine. And that's at the Columbia Scientific Balloon Facility, which is named after the Columbia Space Shuttle. And right now, the holder of that contract is Peraton. So what do we do? So the way to think of our program, what we do, we're a launch service provider. So like any commercial rocket or a government rocket, typically we're just a thing to lift a thing. So you bring us your thing, we integrate it, we strap it in, and then we will fly that thing for you. And to do that, we have end-to-end mission prep and engineering support. We provide the balloon and the associated hardware, as well as the command and telemetry services that the payload may need. We also offer payload recovery, which is very, very unique for these kind of science missions. You guys think about rockets. You send up a rocket, whether it's suborbital or even into orbit, you're never seeing that payload again. But with us, we are proud to say that we actively go out and recover that payload for you, as long as it lands on land. If it lands in the water, then sorry, we're out of luck. We can't do that. Well, we could, but it's super expensive. But yeah, so that's really valuable to the science community to get their payload back, because then they can dust it off, put it back together, and refly it. And actually, we have one payload that flies pretty much every year out of JPL. And yeah, it's the exact same gondola and instrument. They go out, they fly it, they bring it, take it home, refurb it, and they fly it again. So that's one of the cool things about why payload recovery is so important. I did throw the bullet in here, hey, about customer power, which kind of goes back to the fact that we're a launch provider. When you bring us your thing, we expect you to power your thing. So we don't usually provide power for you. So you'll need to have your own solar panels and batteries. But I mean, we can do some power sharing in some cases.
Do you guys use like any of the CubeSat standards for payload form factors?
We do. We're less constrained compared to other launch providers like a rocket, because we don't have a skin we have to keep it in. But we do use the standard U size kind of form factor when folks bring us payloads.
Cool.
Yeah. So as far as our launch sites go, we launch on an annual, biannual standard set of locations, and they are a standard set of locations because standing up a new launch site for us is actually a very tricky proposition, because and we'll show it here in a few slides, but launching a balloon of this size and this scope is a very tricky deal. So we need to have the right location with the right meteorological conditions, the right stratospheric conditions to meet our safe launch criteria. So it's not to say we can't go to another site, but it does take a little bit of time, a little bit of money. Now, a favorite question that folks ask is, well, how do you control the balloon when you get to altitude? And the answer is we don't. Because you guys can imagine that, we're flying at 120,000 feet or higher sometimes. There's no air molecules up there. So to have an effector that would actually help out with trajectory control would be mass restrictive. And because that massing impacts your ability to carry science, we go down the path of doing predictions and predictive trajectories based on what we know about the wind patterns as well as satellite weather data. And we got a crack team of meteorologists that's all they do is as launch and float predictions to figure out where the balloon's going to go. And then the very last item on there, just kind of going back to you bring us a thing that when the payload teams come to us with their thing, usually it's integrated into their own gondola, because typically their gondola is going to be fitted to what their payload is doing. And it's typically going to be a unique structure for every different science instrument. So it doesn't really make sense for us to try and provide a standard gondola. It's better for them to provide their own. Any questions on that before I move on?
How long do these maybe you're going to say this, and I should let you talk, but I'm wondering how long, like those weather forecasts, how long in the future do they go?
So we usually look up to, for launch predictions, we're looking no more than 24 hours at a pop. However, once we're up at float and doing our thing, we may look 3 or 5 days out. But really anything beyond about 24 hours, it gets very unpredictable. I mean, we kind of have a general idea, but beyond that, it doesn't take a lot of deviation and dispersion to really send the trajectory off a different direction.
I have a question.
Yes, ma'am.
Can you clarify the word gondola? I'm
Oh.
thinking, it's a thing that they put their thing in.
Yeah. No, that's. I'm sorry. I used a term that's so common to us. So yeah, gondola for us.
In Venice.
Yeah, it's just it's basically just a steel cage or aluminum cage for the most part, and it's all bolted together. Then they'll bolt their stuff onto that.
Thank you.
Yep.
When you do, when you have what's your average length of mission for
I was going to get to that. That's going to be on a slide coming up, but it really depends. I hate giving that "it depends" answer, but it really does. All righty, but I'll get to your question, I promise. All right, so we do provide end-to-end project management as part of our launch and engineering services. For our flights, they can go quite a ways. So we'll manage them line of sight initially, and eventually, once they get over the horizon, we're talking to them by satellite. We have an operations control center, which is located in Texas with our contractor. It can handle these long duration flights and super pressure flights. And we can actually handle up to 3 in the air at the same time, which is pretty exciting. We actually demonstrated this again last year when we were in Sweden. So from Sweden, we launched to the west and land in Canada. And we actually launched 3 within 3 days, and we had 3 balloons going, which was pretty cool. Now, granted, they landed all over the place, and I should have put a slide in there to show that. But yeah, that was pretty slick. But yeah, we can have 3 payloads in the air at the same time. We handle all the telemetry and flight management. And just as importantly, we make sure that data gets to the user, because obviously that's why they're flying with us, is they want to get their data. And we handle the communications, FAA. And then very last bullet, as stated previously, recovery is important to us, and it's a hallmark of the entire program. Okay, launch locations. So the two locations in red are our primary sites. So on the upper left, we're flying out of Fort Sumner, New Mexico, which is where we got a campaign going on right now. And after I'm done talking, I'll drop a link in the chat where you guys can actually go to the website and see what flights are in the air when we're launched. So as mentioned earlier, we actually did have one launch this morning. It was only up for a few hours. It was a short mission. But that is our primary annual site. We do usually, anywhere from 7 to 12 flights out of there over the course of a couple months. Our other primary site is in the lower right, and that is McMurdo Station down in Antarctica, which I'll be going to this our winter, their summer. And that's our long duration balloon facility where we can have flights go for quite a while because it's constant sunlight. Beyond that, we do have other places that we go. I already mentioned Sweden. We have a site in New Zealand, which we try to go to every other year. We have Australia. We haven't been there in about 15 years, but we do have a site there. We've flown out of Hawaii on the left there. So quite a number of places around the globe, but these are really our standard sites because we've got the infrastructure, we got the right launch conditions and everything we need, and they're predictable for what we need to do the flights. Okay, so eye chart, a lot of words on here, but this addresses your question about how long. So the thing to pull off this slide is we fly heavy things to high altitudes for a long period of time. So we have two basic types of balloons. We have zero pressure balloons and super pressure balloons. Zero pressures can lift up to about 6,500 pounds of payload up to in the 120-ish thousand feet range. Although I do have one balloon that can get up to 160,000 feet. The super pressure balloon doesn't lift as much, and it typically hangs out around 110,000 feet. But these guys can fly for a few hours to a few days to a few weeks or even a few months, depending on where we launch from and what the weather conditions are. Our super pressure balloon, the ULDB, we're targeting to get that to fly 100 days. We haven't quite got there yet, still under development. But that is a fantastic piece of technology we're working on because the science community really, well, as you can imagine, right, more observation is better. So the longer you're up at altitude observing, you get more data. So that's the kind of thing that we're trying to provide.
I have a question, Craig. Do you control to bring the balloons down? Or do they come down on their own when they're ready to come down?
No, that's a good question. So at the end of the mission, we send the command to terminate it because we want to put the payload down in a very specific area so that we can go get it.
That was one of the reasons I was asking the question. Is there a chance that, when I wake up in the morning, there's going to be a balloon on my deck?
Since you're in Maryland, no.
No.
Yeah, no, we purposely fly and terminate in areas where it's very, very low population, and we have a very active safety program to do a risk evaluation and put it down in unmanned or unpopulated areas because safety is obviously one of our big things at NASA, and we don't want to do anything to hazard the population. All right. Anything else on this?
Is there an easy way to explain the difference between like what is meant by pressure, super pressure? Maybe that's coming up.
Yeah, I'll jump ahead 2 slides and we'll go through that one. So yeah, two types of balloons. We have a zero pressure and a super pressure. So a zero pressure balloon is called that because there is zero pressure across the balloon film. The balloon film is made up of polyethylene and polyester support. But a zero pressure balloon has zero differential pressure across it, and it's vented to the atmosphere. And those provide a lot of lift capability, but unfortunately, they're very much subject to day-night variation. So when it gets when the sun goes down, it loses heat, it starts to descend. And so the zero pressure balloons had a tendency to kind of porpoise up and down through the day-night cycle. So to control that, we have ballasting. And those guys, that's why those kind of balloons don't last as long. They can't go as far. Now the super pressure balloon, which is a little bit of a misnomer. It's only called super pressure because it's more than zero. It's actually a closed volume system. And because it's a closed volume system, it means it has a constant density in there, which means it flies at a very specific pressure altitude. So the altitude variation for that kind of balloon, even day or night, doesn't matter. It's going to be a function of the pressure altitude. So altitude variation is going to be very, very low, which is super valuable because that gives us the ability to fly a long time, because we don't need ballast and we're not worried about venting helium because we're not vented to the atmosphere. So did that answer your question?
Yes, yes.
Cool.
It's amazing that this, you were talking about how the lack of density of the atmosphere that high. It's amazing that this, wants to stay up there.
Yeah, yeah. And just to give you a number, the super pressure balloon, when it is pressurized, it's 0.01 psi.
Oh, wow.
So yeah, so like I said, it's a bit of a misnomer, because people think super pressure, it's really highly pressurized. Well, no, not really. It's just more than zero.
Wow. We saw one of those once.
Yeah, cool.
I have a question for you.
Yeah.
With the climate change and the greater number of um, changes in weather and more erratic weather, is that affecting the days that you're able to launch?
It's we haven't done a long-term study on that sort of thing. I mean, if you look in the micro scale, year to year, every year is a little bit different. We have noticed a little bit of weirdness in the Antarctic pattern in the last few years, where the stratosphere gets set up not quite on its normal cycle. But it's hard to attribute that to any one thing, because the atmospheric patterns over the short term are hard to pin down to as having a single factor that's driving it.
Okay, thank you.
You bet. So I want to come back and look at some payload sizes. So we don't do small. We can do small, but we don't. We do very large, massive structures, and as you can see from these examples here, there's no one form factor. It really is depending on what the science team wants to see out of it, or wants their instrument to do. So yeah, they can be super big or medium sized, but yeah, it's all shapes and sizes.
I have a question. So some that big hanging from the balloon, does it wobble a lot when it's moving around, or is it, because it does this, the science project hold pretty stable, or is it flopping around like a umbrella in the wind?
Yeah, so once it's up at altitude, it's extremely stable. Now there is some rotation because of the atmospheric drag on the balloon. It has a tendency to kind of spin the balloon one direction or the other slowly, very, very slowly. But as far as like swinging back and forth or bobbing up and down, there's none of that. Or if there is, it's so tiny, it's not even worth worrying about.
Right.
All right, so lift capability and sizes. So we don't just have one balloon, we actually have a whole stable of balloons. So when the science team comes to us and say, hey, look, I have this thing I want to fly, one of the first questions we ask is, well, how heavy is it and how high do you want to go? And more often than not, they say it's super heavy and we want to fly as high as we can. But regardless, they'll tell us, we'll figure out, well, okay, based on what you want to do, this is the kind of balloon that can support you. And there's one balloon on here that I haven't advertised, and that's one of our little, we call them hand launch balloons, but they're just small 1.1 million cubic foot balloons. And they're off in the lower left column, around between 100 and 120,000 feet, with carrying about 300 pounds worth of stuff. In the upper left, though, I do want to point that one out, the 60 million cubic foot. That is a massive, massive balloon, still under qualification, but we'll get that guy up to 160,000 feet, which is impressive. There's only been one other balloon that's gotten that high. The Japanese have done it in a slightly smaller balloon. But yeah, that is a tricky one to launch. So the thing I like to point out is, well, I just said balloon sizes based on 60 million or 1 million, and folks are wondering, well, what does that mean in the real world? Well, first off, these balloons are not small. On the very left-hand side shows what it looks like right before we launch, before we let go for the launch vehicle. You can see from payload to the top of the balloon about almost 900 feet, bottom to top, with a little bit of bubble at the top. That's all the helium we put in it on the ground is up in that bubble there. And that goes back to why I said that it's tricky for us to find a place to launch, because we need to have very light winds, very stable winds, to a minimum of 1,000 feet, but really up to even 3,000 feet, so that we have a stable, safe environment to launch the balloon through initially. Now, once it gets up to the stratosphere, and that little bit of helium we put in on the ground fully expands to the volume of the balloon, you can see it's a massive structure, right? So this is a 39 million cubic foot balloon. And the reason I'm showing it is it's one of our workhorse balloons. We fly this one quite a bit. But yeah, you can see it's 460 feet across. It's just a monster of a balloon, as big as the the Washington Monument. And the thing I also like to compare it to is, well, you know what? It's actually bigger than a football stadium. You could actually fit a football stadium inside the balloon, right? And one of the cool things about it, or many cool things, is you can see this quite easily from the ground. I mean, you can see, 460 feet across. When that thing's floating at 120, 130,000 feet, it's like it's right there in front of you. It's just so big. And we get so many calls about aliens and UFOs in New Mexico because this thing flying around out there.
Is Roswell one of your launch sites?
No, no. But we're not too far from those guys.
I go there.
So just to use 100,000 feet as a nice round number, what is the average amount of time it takes for a balloon like this to reach that altitude?
Yeah, it depends on the location, but anywhere from 2 to 3 hours.
Okay, thanks.
And it's less than 1,000th of an inch thick. So
Yeah.
What is it? What is the material? Is it Kapton or what is it?
No, the balloon's made of polyethylene.
Oh, wow.
Yeah, especially designed polyethylene, right? With polyester reinforcements on the seams to help provide strength.
Wow.
Do you use interns to blow them up? Just
We have a whole army out there filling it up with helium. Yeah.
Has one ever popped?
Oh yeah.
Oh, my God.
But I will say that was a long time ago. All right. We designed that kind of failure out. Yeah, back in the and I mean a long time ago. I mean like back in the 50s and 60s. It was this whole science of ballooning and using plastic materials to do ballooning was still very nascent and new. So they didn't know what they didn't know. And yeah, every once in a while a balloon would pop, or it had a thermal issue where it got too brittle and cracked and popped. And so yeah, they went through a lot of cycles to figure that out. And today that does not happen.
Wow. Incredible.
So how far could the balloon travel across the globe? You could pick any location you want to start from, but could it go? How far around the globe could it go before it runs out of steam, if you will?
Well, it depends on the balloon. So like a super pressure balloon will go around the globe constantly. And I've got a picture of one later in the presentation of one of our missions where it went around the Earth 5.5 times.
Wow.
But our zero pressure balloons, they're really only good for normally a couple of days, 2-3 days. at most, unless we're flying out of Antarctica, which is where we do zero pressures out of Antarctica. And because it's constant sunlight, those can actually go for several weeks. Anything else on this one?
No, just me.
Okay. Yeah. All right. So the previous slide showed the vertical. Well, this is what it looks like in the horizontal right before launch. So this is out of Antarctica, out of McMurdo. We got everything all laid out, and it's a very complex choreographed set of actions and things that have to be done to get this all laid out. But the whole train starts with a launch vehicle on the right. You got the parachute connected to the balloon, and at the very end, and at the end all the way, and you can see the bubble on the very far left. And the thing on the very far right that's hanging off the end of that crane-like thing, it's hanging off the end, that's the payload. So that's what it looks like on the ground before we let go. And then when we do let go, we do what's called an active launch. So at the spool, which is shown on the very left-hand side there where it says spool vehicle, once it lets go of the balloon will rise up to the vertical position. The launch vehicle will then position itself in just the right spot and then let go of the balloon. So we do that as an active launch because that way we are working with the wind as opposed to fighting the wind. All right, then as far as the flight train and the payload goes, again, heavy lift kind of stuff, reusable systems, pointing systems. We'll talk about pointing systems a little bit later in the pitch here. We do have two kinds of power, solar and battery, that can be used. And as mentioned previously, missions go for hours or days, weeks, depending on where we launch from. So timelines. So, at the very beginning of the pitch, I said, hey, we're agile, we're quick, quick response, that sort of thing. Well, that's still kind of relative. Compared to launching a payload or a satellite on a rocket, those guys take years and years and years to get ready to launch. Us, well, not as much, right? There's a lot more forgiveness in our systems and what we're doing. So typically, we'll get folks about the 2 to 3 year mark ahead of when they're ready. And really our schedule is kind of driven by the science team and them getting their own instrument and payload ready to go. If they came to us fully ready to go, we can knock them out in less than a year. And we do that with some of our smaller payloads. We have what we call piggybacks, which are little tiny, like hand size, less than 50-pound kind of payloads. They'll bring us a box, whether it's 1U or 2U or whatever, and say, hey, look, I got this thing I want to fly. Do you have some spare room? And typically we always have a little bit of mass fraction available on one of our gondolas. So we'll strap that on and fly it. And we can do those pretty quick, anywhere from 1 to 6 months ahead of time. So pretty quick. Yeah, I don't need to worry about that bottom bullet. And then as far as milestones, we do have a series of key milestones that we have to meet. Again, starting at about the 2.5 year mark, we'll have some tag ups with the science team to make sure that they're on track, because we need to make sure that one, they meet our safety requirements and as well as NASA safety requirements. We need to make sure that their systems are going to integrate with our system. So it's a series of meetings and discussions over the years and over the months to get ready to launch. And that all leads up to L-2 days for final integration, and then on launch day, off it goes. But this is kind of a nominal timeline. If it's an international mission, that can be a little bit longer. And then for the actual day of launch activities, that whole thing on a good day takes about 3.5 hours by the time they pick up the payload to the time they release it from the pin. So it is a very well-rehearsed, choreographed set of actions they have to go through. But it really depends on the instrument and the winds and the weather. So I've had launches that sat around 5-6 hours. when we're launching out of New Zealand, sometimes that takes us 11 or 12 hours to go from pickup to launch. So really depends on the balloon and the weather that day. So 3.5 hours to launch. And to the question we had earlier, it's, you know, about 2 or 3 hours, so 2.5 hours to get to altitude. Although when we're flying out of Antarctica, that can take 4 to 6 hours because it's just colder. Again, no trajectory control, and we do have control termination, which I spoke about earlier. On the lower right-hand corner of the picture here, that's what we use for our risk map. It's a color-coded heat map, kind of tells where the safe spots are. So green is good, yellow is okay. Anything else beyond that is places we don't want to go. And that corresponds to population and other things. And that's New Zealand for those who
Governments that get upset that the balloon is flying over their country.
Yes.
Oh.
Yes, that's actually a challenging thing we have to go through every time we fly out of New Zealand. Is we'll spend months coordinating with all the countries to get permission to fly over their country, because we won't do it. If they say no, we're not going to fly over their country. I mean, we're NASA. We're not going to cause any problems. We're not the Chinese dudes who will fly wherever they want. So it is very much a diplomatic effort that we have to go through with our our international folks to get that permission and be good neighbors and good hosts as we fly over their country and over their airspace.
So does that have a factor then in your launch site? Because you said, if I heard correctly, that you don't have any control over the trajectory once it's up there.
That's right. So yes, that does absolutely play into our decision on where to fly. And that's kind of how we ended up with New Zealand. New Zealand is in the southern hemisphere, and where we're at is on the South Island. So we're around 40 degrees south latitude. So at that latitude, we're not flying over a lot of countries. So it's a little bit easier. It's still still a number of countries we have to talk to, but yes, the location and the winds and the countries we fly over are all related. So, for example, when we flew out of Sweden, a long time ago, we actually had a flight that went over Russia. Well, that happened one time, and we haven't done it since, right? So that's why from Sweden we only fly to the west and land in Canada, because obviously Russia's not our friend these days. They're not anybody's friend these days.
Andrew, I had a quick question. I'm a university export control officer, and I, supervise these research security on research projects. Do you guys also have to do an export control review for some of the payloads that you're sending up? And is also the balloon export controlled too with the technology you're using on that?
Yes and yes.
Okay.
Yeah, so that's actually a big deal for us when we do our international campaigns. The payloads generally, the science teams generally take care of themselves, although we do assist some. But on our side, with the equipment we're sending and the balloons, we got to go through all of that rigmarole.
Thank you.
You bet. All right, some additional capabilities. So control authority. So I mentioned it earlier, rotation. So we have a couple different kind of rotators. One is just a coarse rotator, will get you within 1 degree of target. And then we have something called a WASP, which I'll get to. It has its own slide. We do hand launch mobile campaigns. And then we have done in the past a balloon assisted rocket launch development. And I'll show that one here in a second. All right, so WASP's arc second pointer. Now this is a super cool piece of technology. What this is a rotator system and a pointing system that allows us to get sub-arc second pointing accuracy. So an arc second, since you guys are astronomy, you know that an arc second is pretty small, 1/3600th of a degree, and we can get pointing to less than 1 arc second. And actually back in 2022, we had one of our payloads get to 0.1 arc second. So that's the kind of thing you see on James Webb. And I actually spelled that wrong. Sorry, it's James Webb, W-E-B-B. So that is a super cool piece of technology we fly. A very complicated piece of gear, but it does some great science. It allows us to get some really good, strong observations and clear observations. All right, hand launch campaigns, and this is a bit of a misnomer as well. When I say hand launch, it's literally just two of our guys picking up the payload by hand and letting the balloon take it away. So it can weigh up to about 150 pounds. But the only reason it's called a hand launch is because we're not using our big giant launch vehicle. And the cool thing about these type of missions is these are much more mobile. So we are less restricted on launch locations with these guys. We can set these up pretty much anywhere, depending on what we need to do. And the example I have here is a mission we did out of Sweden called Barrel. They flew quite a number of missions out of there for over the years. They've done quite a bit. Let's see, supersonic flight using a balloon. So a few years ago, we flew a mission out of Hawaii called the Low Density Supersonic Decelerator. And what that was a rocket that we carried to altitude, and then they launched the rocket from the balloon. So it's conveniently called a rocket balloon. And the purpose of that particular mission was to test out the parachute that they were going to use on one of the Mars vehicles. So the funny thing is the stratosphere is actually a really good analog for the Martian atmosphere. There's no pressure up there, very little pressure up there. So it's a great way to test out that sort of thing. So that was something we did for them. They launched the rocket, and then it got set up, and then they tested their parachute. And fortunately and unfortunately, the parachute actually failed, but they learned a lot from that. And then they came back a few years later, and they did the same similar testing on a small suborbital rocket, and that one worked. And then that particular parachute design was then used for Mars. So this is a cool capability that we have that, if needed, we can fly rockets up to the stratosphere. Okay, so a couple highlights on a couple of missions. So Gusto, I love talking about this one. Gusto was a huge success for us back in FY24, fiscal year 24. So we launched in December of 2023, and that guy flew for 57 days, 7 hours and change. That was a record for us. It was a huge success. They got a lot of magnificent science from their observatory. And for this particular one, they were looking at the space between galaxies, because there's not a lot known about what's going on between the galaxies. Although there, recent articles that have come out about that, they're starting to see more and more matter that's out there. But this was one of the one observatory that's going to examine the space between the galaxies, that interstellar medium. Oh, and the other thing I like to point on this particular one, because it flew so long, it actually flew through turnaround. And what turnaround is when the stratospheric winds go from one direction to another. So a funny thing about the stratospheric winds is they generally are flowing either east or either west. And twice a year, they'll just flop directions. And so we plan our missions accordingly to take advantage of those winds in the direction that we want to go. But because we flew so long, it actually flew through turnaround and went back the other direction. So you can see on the third pass on the red trajectory, it got all the way around till about 12 o'clock, hung out, went a little bit north, and then started heading back the other direction. So that was very exciting for us. All right, Superbit. This is one of our missions that we flew out of New Zealand. This is the one I told you went around the Earth 5.5 times. So you can see this goes back to the question you had about countries and getting permission to fly. You can see, down in that part of the world, we're really not flying over a lot of stuff, right? We do South America so Chile and Argentina. We have really good relations with those guys. South of Africa, south of Australia, and of course, near New Zealand again. But yeah, this is a super successful mission for us. It went 39 days. It actually could have flown longer, but we decided to end it a little bit early because some concerns we had about which way the trajectory was going. It was actually going to have it start trending a little bit too far south, and we didn't want to do that. But that was a great success for us. And so that's kind of all I have to talk about today, and I'm happy to take more questions.
Well, I have another question for you. With all of the debris that is in the stratosphere, have any of the balloons ever collided with any
So great question.
satellites?
Yeah, no, that's a really good question. So the stratosphere is actually fairly sparsely populated up there. There's not a lot of stuff up there. However, it is starting to get a little more congested because there are more balloons, and there's definitely we're starting to see some unmanned vehicles that want to fly up that high. So no, we've never hit anything, and nothing's ever been hit up there. But at some point in the future, it probably will be an issue. And that's actually a problem we're trying to tackle today. I mean, I've been working with the FAA and other agencies on, well, you know what, how are we going to not control, but do the reporting and the identification of what's going on up there? I mean, when we're up there, we have a transponder, so we let everybody know where we're at. But other vehicles, maybe not. So there's a lot of coordination that may have to happen in the future as the stratosphere and that airspace above 60,000 feet starts to get more and more congested.
When you deorbit, what happens with the helium?
So yeah, when we terminate at the end of the mission, the way it works is we just rip a hole in the balloon and the helium just goes out into the atmosphere.
Do you have one big customer or just a lot of little customers?
We have a lot of customers. I mean, we have a couple of folks we fly routinely, but yeah, we have customers from all over. You know, from all the different sciences. We have international customers. So yeah, there's no one place that we point to.
You run citizen science projects?
I have, but it really kind of depends on what they're asking to do, because we have to be very careful about that. Because some people will bring us the craziest things that they want to fly, and I have to politely tell them no.
They have more than one little brother.
Yeah.
You have like 15 flights a year, but it takes 3 years to get there. Do you have a lot of teams, one for each flight?
So I actually have a small handful of mission managers, about 3 right now, that manage all those flights. So it gets busier during the campaign when we're actually flying them. But each campaign manager is handling anywhere from 15 to 20 missions at a time, depending on where they are in the cycle. So some are far enough out where they're only talking to them maybe once a month, but as we get closer, they may be talking to them every day.
Any other questions online? Or in the room? Okay, well, thank you very much. That was really, really, really interesting.
Well, thank you all for letting me talk a little, and I'll drop in the chat the website to where you guys can go look at our current campaign, and maybe you'll be able to log in and see when we got one in the air.
Terrific.
Very cool stuff. Thank you, Andrew.
You bet.
And you're welcome to, we're going to keep going with the meeting. You're welcome to stay on if you need to run, so we understand. Again, thank you. That was so cool.
Yeah, you bet.
All right, so I'm going to go ahead and grab the screen again. The folks online, can you now see my screen?
Yep.
Yep.
Okay.
Yes.
Okay, so that was really cool. So let's move on. So next up on the agenda, we have our what's out in the sky. And I see you're ready to go there, Jim. So let's let you go ahead.
All righty. Well, this morning, Mercury had its greatest western elongation. Obviously, with the clouds, nobody here caught that. But right now, Mercury is having a great apparition, great appearance in the pre-dawn sky. Usually, fall in the morning, pre-dawn is best for Mercury, and spring for the evening. So if you have never seen Mercury and you want to try to catch it, this is really a good time. Now, probably through the weekend. It's very fast moving, so even by the middle of next week, it's going to get a little bit more difficult to see. So if you don't have a clear eastern horizon, but you do have a go-to telescope, you can certainly try catching it during the daytime. Basically, what you could try doing is getting your telescope aligned at like 5 o'clock in the morning when there's still stars out, and you can do a 2-star line or whatever. Get it locked in, and then once Mercury is up like 30 or 40 degrees, use your go-to to go to Mercury. And I would recommend a red filter to kind of darken the blue background. But it is very doable. And right now, while Mercury is so far away, 20 some degrees from the sun, there's less risk of you having an issue of getting the sun in your field of view. At any rate, the Alpo did a very nice webinar. That's the link here about how to do daytime planetary observing. So if you're interested, I'd recommend you check out their YouTube video there. Next.
Cool.
Click it one more time here. There we go. So Saturn is going to reach opposition on the night of the 21st. I think we have a star party on the night of the 20th. As noted last month, the next couple months, these rings, because of the dynamics with the Earth, kind of like sinking as it looks from Saturn below its equator rather. Those rings are going to tighten up. And by the time we hit December, they're going to be almost edgewise. So it's not going to be spectacular looking at the rings. But again, you've got just a couple more passes, I believe, where Titan cast a shadow on Saturn. And the next chance is going to be September the 4th coming up. So that one will be at 1:30 a.m. for about 3 hours. And then unfortunately, the night before our star party, I think the 19th, so very early morning hours of the 20th, will be the next one. You can see these if you have a probably 4-inch or better telescope and you're patient, you wait for the good seeing, you can visually see that spot just like you can on Jupiter, like when Io or Europa or one of those satellites crosses in front, except this is much more rare. So if you have a chance, you may want to catch it because otherwise it'll be, I think, like 14 or so years before you'll have another chance.
Hey, Jim, I was out last Saturday, very early in the morning. And I was visually looking at Saturn with my 5-inch refractor. And even with the rings, how they're kind of almost edge on there, it was a really cool view. Because it's really nice when you can see through the rings when it's on, when it's like a plate, like a dinner plate. But because we don't see it this way very often, it was more interesting than I was expecting. I mean, I was really pleasantly surprised.
Yeah. The glass is always at least half full, right? I mean, even though we don't have these rings and their beauty right now, it is so cool to see the full planet. And again, I don't know how easily this could be observed depending on your scope and how long patient you're going to be looking at it. But the southern polar region is definitely a much deeper blue color right now. So it would appear darker in your when you're examining it. So yeah, definitely give Saturn a look here. It's coming to opposition soon. And even though those rings may not be spectacular, it's still a very cool object to look at. Next. And then my favorite, Jupiter, it will reach quadrature in mid-September, which is basically, it's like a quarter of the way or halfway of the way to opposition. So when the sun comes up on the 12th, Jupiter will be right on the meridian at its highest point. Click again if you would, Victor. So looking at Jupiter, it's like, it's always something going on. I love it. One of the things is, has the North Temperate Belt reformed? We don't know. What is the Great Red Spot going to look like? You can see here the Great Red Spot is on the bottom left-hand side. You can see above that the arrow is pointing to its equatorial region, which looks very chaotic. I don't know what's going on with that. This is, by the way, an infrared image. And down below, you can pick up another oval there, which is oval BA. And another very curious thing is this, the darkest thing in IR here was that spot there. And it's like, so what the heck is that? You know, that's darker than the equatorial belts. So, you know, there is always something cool and active going on at Jupiter. And those, I think, are my main tips for if you're looking to the shallow sky for this month coming up.
Thanks, Jim. And Jupiter is going to be, I'm super excited about Jupiter this year. It's going to get pretty high up in the
Yeah,
sky.
it will.
But that won't be for several months, right?
I think the opposition is in January. We technically do not have an opposition of Jupiter in 2025. It skips into January, so
That's
early
fine.
January.
Okay, well, great. Thanks. Anybody got any other questions for? Oh, we got a question in the room, Jim.
We got in late, and maybe you already covered this, but are there any updates on 3I Atlas?
We did not cover it, and I don't know if does anybody know? The question was, are there any updates on the interstellar comet, the 3I Atlas? Has anybody read anything recently?
I think I saw that they imaged it with the Hubble, and it does have a little bit of a tail, but I've not seen a whole lot of information. I'm sure as it gets closer, we'll hear more.
Is it not a comet? Does anybody? They don't know what. Yeah, I'm calling it a comet because I think
it is a comet because it's sporting a tail.
Yeah, you know, there was something this morning, but you just never know when it's real science being reported or somebody's opinion. Sometimes
Yeah.
you get to read the whole article, but they were talking about they don't know why it's generating that kind of light. And they think it might be nuclear fuel, like the star, but I didn't read the whole thing, so I don't know where that was coming from. You know,
Yeah,
somebody could have been drinking for all we know.
Yeah.
The journal Science has covered it a bit. But,
Yeah, I mean, it's going to get a little bit closer in the upcoming months, so maybe we'll go to Roswell and see what's happening. Okay. Thanks. So now I'll just get into the images. If you're online and here and you see your image, please let us know and speak up and tell us about it. So first off, we have Sundar. Are you here, Sundar? Are you online? Yeah,
I'm here. I was with Sundar.
Yeah. Can you tell us about this? Did you help him process it or something too?
I did. I edited it just with a standard editor, and then I did a little bit of editing with GIMP too. But we went to Blackwater Falls State Park in West Virginia, and I've been there several times. It's really impressive, a really cool place. You get a really awesome view of the Milky Way just with the naked eye.
Cool.
It's Bortle 4, and in my opinion, it really allows you, in terms of standard visual observing, but imaging too, it just really allows you to go to another level. For me, it's 4 hours. For Sundar, it's 3, but in my opinion, it's worth it to put that kind of time into it.
I couldn't agree more. I like getting out west when I can.
You go out and camp and then
He got that with his Google Pixel 6.
Oh,
Just
with
with
the
this,
phone? This was with the phone?
yeah, this was just with a phone.
Oh my gosh.
And I don't think it's a new phone either. So newer ones would probably do better.
We had a question in the room?
Yeah, so do you, like when you go out to the places, I mean, do you just like drive out to do an overnight, drive back,
Are
or?
you asking me or?
Sundar and I reserved a room at the lodge. It's the Blackwater Falls State Park Lodge. It was $180. We split it up the middle. I've gone there just on day trips where I leave by 10 or 11 and get back here at 3 in the morning. I've done that kind of thing. I've been there several times. But you have to get a pass before 5 o'clock.
Okay.
You have to get a viewing pass that the Rangers give you. And we, Sundar and I wondered if our group could try to reach out to the park and see if we can get access to the park, because they don't let you, they don't give you access to the restrooms, not the restrooms that are right there at the parking lot. They're kind of down the road a little bit, like a quarter of a mile away.
Depends.
Yeah, well, that's excellent. There's a couple of spots where I also, and I do camp usually. Usually just bring my car and camp, or there's two Bortle 3 places within a couple of hours out near the C&O Canal that I tend to go to, and then another one a little farther west and that's more like 2 hours away. But yeah, we can Phil and I go out every once in a while to a place called the Roadkill Cafe and Cabins. And it's just a little place. It's just across the border into the town is called Artemis, PA, Artemas. And it's just some cabins, and they got a nice little restaurant there. And it's Bortle 3, and it's only about a little more than 90 minutes from here.
Wow.
So
We don't
yeah.
tell anybody that.
I need to, I want to have a remote, we keep talking about it, but it never seems to materialize, but I want to have a kind of a remote star party for the club. Every once in a while, Phil and I go out there together and a few others. So,
That'd be neat.
yeah.
Well, an added benefit of Blackwater Falls is that it's just so spectacular there, just the park, and then so many things that are within like 30 minutes or less, like Seneca Rocks.
Yeah.
You've got a 750-foot gorge right there at Blackwater Falls Park.
Yeah.
Waterfalls, numerous waterfalls. So there are other things you can do if you get there a little bit early.
Yeah. And I think the altitude, you're a little higher there than it is around here in Maryland. So
Yes,
helps,
that's
too.
in Davis, West Virginia, and it's the highest town in West Virginia at 3,500 feet elevation.
Well, it speaks to the quality of the skies there that he was able to capture this with a phone. That's amazing.
Yeah, I was pretty impressed.
Yeah, so thanks for sharing and describing all that. That was really cool. James is never online, so I'll just mention that we talked about these transits, and we got a few transits in here. So this is one he did say when he emailed me that the scene wasn't particularly good that night, and I'm not sure why his colors are like that, but maybe we got to get James to stay up late one night and talk to us. Jim?
Yeah, so here's my contribution for the Titan Transit. It's taken with white light, so in other words, just a color camera. Lucky imaging capture here. You can see Titan there to the upper left-hand side. And you can see what I was talking about at the bottom, that south polar area. It's definitely got a little bit more of a darker bluish tint to it.
Yeah.
Really kind of cool looking. And this was Venus. This is using a UV filter. If you use a UV filter, you can actually capture some of the cloud details. Can definitely see like what they would call a southern cusp cap there, and not quite see the one in the north, but I just always find it cool to be able to see actual detail, even though it's the clouds on Venus. And finally, here is Mercury from last weekend. And this was, as I was saying, a daytime effort. This was like 9 o'clock in the morning with a IR filter. And I'm not sure, I think I can almost make out a little albedo feature there. So I'm hopeful to give it another try this weekend and maybe get another Mercury image. This is the first image of Mercury I've ever been able to capture.
It's amazing. And Steve, are you on?
Yes. Um, yeah, these are, well, it's my picture of the Titan shadow 2 weeks ago. And on the left is the supernova that's in NG7331, taken on 2 of the clearer nights. And I think I can see, I haven't been able to find out about it, but I believe it looks like it's dimming now in the on the 16th. It looks like it's dimmer compared to the center of the nebula, the galaxy. But you can see it's spectacularly bright if you were in the galaxy or if it were in our galaxy.
Wow. Yeah, when are we going to get one of those? It's been a while.
I don't know whether we want one of those or not, that close.
And it looks like you got the transit around the same time.
Yeah. Mm-hmm.
Okay, thanks. And now these are 2 that you had sent me and got caught in my spam filter, so I didn't show them last month.
Yeah, this was with the Hyperstar on my 14-inch and the Optolong Extreme filter. It's a mosaic of 13 sets. I think I could have done it in fewer if I'd planned a little better ahead of time, because it is pretty big. The Hyperstar gives me about a 2-degree field. So I got most of it. And
that is beautiful, Steve. That is just gorgeous.
Yeah, it's pretty spectacular, and each different filter you use gives a completely different view of it. This is an all-color uh, camera, the ASI 2600 MC. With individual color filters, you can get all sorts of different effects.
Yeah,
And yeah.
You know, the Optolong does a good job of getting the important wavelengths.
Yeah.
Yeah, and then the lobster as well. Beautiful.
And the one on the right is the so-called Lobster Nebula, which is quite low in the sky, but I'm able to get down fairly well in the south when I was able to get a pretty decent shot of it again with the extreme filter, which is a multi-band, narrow band filter.
Right. Okay, thanks. Jose, are you on? This is the Crescent Nebula and Cygnus, and it's pretty impressive. I love seeing Jose come along in his astrophotography. This is really, really quite nice. This thing always looks like a brain to me. Chris, are you on?
Yes, I am.
Can you tell us a little about?
Yeah, this is the North American Nebula and the Seagull Nebula in narrowband SHO. It's a 2-panel mosaic shot with my Apertura 75Q and a monochrome camera from Starfront Observatories in Texas. About 28 hours total exposure across the 2 panels.
That is so cool.
The awesome thing about having a telescope in Texas, though, is that 28 hours was really only about 4 nights.
Wow.
So I got this data in like a week.
I'm jealous.
Trying to do that kind of thing from home would be multiple months, probably.
Yeah, that is really gorgeous. And was this part of the Cygnus Wall challenge on the?
Yes.
Yeah, so the Cygnus Wall.
Although, so this is the 2-panel mosaic I only submitted the North American part for
I
the
see.
Cygnus wall.
Yeah. Well, this is amazing. Your Pelican was, again, I want to rename everything. I call this the Pterodactyl Nebula. That's really quite a gorgeous Pelican too.
Oh yeah, what did I call it?
No, you did. You called it the Pelican.
Oh, okay, all right.
Yeah,
I sometimes call that the Swan by mistake, but I get confused because it's
Oh,
been
did you?
Cygnus.
Maybe
And then,
I don't know. Maybe you did. I don't know. Anyways, next one is mine. And where's my mouse? So we were talking about dark sites. So I took this from the dark site that I like to go to in Western Maryland called Wolf Den Run State Park. And this was taken over 2 nights. It was a month and a half or 2 months ago when we had that heat dome. Um, so I was camping on this ridiculously hot days and nights. But yeah, I got this with my 5-inch refractor and also used an ASI 2600 MC Pro. Um, and yeah, so that was 2 nights then. And I have a piggyback set up. And this was just using regular UV-IR cut filter, no special filters, because that's what you need to catch all this dust and white light. And so at those same 2 nights, I have a little Nikon lens with a ASI 294, and I was able to capture the wide field version of it. That's the same thing. You can sort of see it's just a little bigger. And there's a lot going on, a lot of dust there. And then our last image of the night is Phil, who spent quite a bit of, well, I'll let you talk to it.
Yeah, so it's interesting, when the average person, somebody who's not into the hobby, into the science and everything else, takes a look at this, they say it's a nice picture of the moon. And, but that's about 8 hours of work. It was last Saturday and, the skies weren't that bright last Saturday, but they were almost cloudless except for a thin layer up there. And so this was a planned shot. I set up at 10 o'clock at night. The moon came up over my house at about a little after 1 a.m. And I stayed up till just before the sun came up, and this was a target. And so this is Copernicus, which is a pretty easy to see crater, even visually, just look it up. But to get that kind of detail, I was blown away on how much I was able to grab. So that was with my 5-inch f8 refractor, and I put a 4x Barlow in there, a PowerMate, TeleView PowerMate. So I was at a little over 4,000 focal length, 4,064 focal
Millimeters.
length on this thing. What's that? So it was a long lens. And what's exciting about it, and you can see it better on a computer screen, but to get that kind of detail from my backyard over by BWI, and with all the light pollution, I had such a hard time polar aligning and getting everything set up because there was a thin layer of clouds, total light pollution. I could barely see stars to set up on. And but it was tracking great. Otherwise, it would have run right on that field of view. I didn't have any movement. And so I was able to get the center areas. And you could see, I forgot my laser pointer at home. I was gonna put it for those of you on there, but if you go around you could see the spray from the crater hit, and it's really huge. And what I'm excited about is just the amount of detail I was able to capture. I compared it to a satellite shot, which was obviously better, but you could still see all the ridges in there. You could see the depth in this thing. There's so much 3D. And just a little bit, if you go right to the center with the arrow there, of the crater. And then, and we just, have a great weekend. No, there you go. And then if you go to the right and up just a tiny bit, it's hard to see here, but you can see Stratius, which is called the ghost crater, because it's almost totally filled in. That, to put this, and then this is Kepler over here. And these are two, I brought my, I can't see too much in the dark here. I have my notes, but and this mountain range is the lower part of the Mare Imbrium. So There's so much to study in this image, and there's so much that's written about it. I mean, pages and pages between the book I have here and Cognita, that whole series and everything else. But it just was fantastic. I was so excited. Yeah, it took me about 3 hours when I got home of processing to pull out all the detail and get it, the shadows right and everything else like that. But this is why I'm so excited about it, just because I was able to grab that kind of detail. If you go back later on, this is, and if you look at the picture I took back there on the wall back in 2013, and you look at the moon straight up, this is not the telescope view. It's just over the equator, to the west on the left side. It's very large. And you can see up there is kind of a blur because it's washed out because there's a lot of reflection. Albedo but here, same shot, but in so close. And that's why I'm just super excited about it. I look at it every day. It's not just because I like looking at my pictures, because I can see so much. And to do that from the backyard was really,
Well, it's quite impressive.
yeah, so I'm looking forward to another moon night out there where it's got a good sky and a nice terminator line to work from, because you take that shot again another time, you get a whole different view.
Okay, well, thank you. I want to thank our speaker again. Looks like Andrew's still on. I don't know if anybody thought of any more questions. But it looks like Andrew's still here. It's kind enough to stay on. Other than that, I'm going to stop the recording, and we've got a few minutes, so if we can just kind of hang out and talk for a little bit. Anybody online, you're welcome to do that too.
There goes